Structural failure rarely begins with a sudden impact. It starts at a microscopic level, with a hairline fracture splitting a single brick. This localized cracking indicates that the entire multi-story building is shifting, slowly leaning outward as the internal stresses of the masonry exceed its breaking point. A failing foundation creates a dangerous technical paradox. Leaving the building alone guarantees a collapse, but removing the dirt to fix it can instantly destabilize the wall. Underpinning is the engineering process of building a new foundation underneath an existing structure without disturbing its equilibrium. To achieve this, engineers must manage the dead load, the constant downward force exerted by the building's own massive weight. The operational plan to manage this weight follows a three-step agenda. Step 1, the bypass. Step 2, the excavation. And Step 3, the transfer. This process relies on shifting the massive load of the masonry onto temporary supports, creating a stable bypass that allows the ground to be excavated and replaced in sections. Before the ground is touched, engineers independently support the internal floors and roofs to relieve the exterior walls of that additional weight. On the exterior, raking shores are deployed. These angled timber supports are designed to resist any outward leaning or bulging forces. This schematic shows the relationship between these two interventions. The interior floor strutting presses against the wall from the inside, while the raking shore braces it from the outside. These combined structures lock the masonry in place, preventing the lateral movement that leads to collapse. Stabilizing the building's weight through this shoring network provides the structural control required to safely begin excavating the base. The first invasive step is cutting rectangular holes directly through the masonry wall, positioned precisely just above the failing foundation. These holes are cut at strict intervals of 1.2 to 1.8 meters apart, ensuring enough original wall remains to support itself. Heavy steel or timber beams, called needles, are inserted through these holes to temporarily carry the weight of the structure above. Wooden bearing plates are wedged between the needles and the masonry to prevent the concentrated pressure from crushing the bricks. The ends of these needles are supported by cribs and hydraulic jacks on the ground level, holding the horizontal beams in a fixed position. The building's dead load is now successfully bypassed. Gravity flows through the needles and into the ground supports, leaving the old foundation unweighted. With the weight diverted, workers manually excavate the soil and the old foundation directly beneath the now suspended sections of the wall. The underlying excavation zone is tight and constrained, requiring the manual removal of crumbling concrete and rocky soil. The dig is restricted to tiny lengths of 90 to 120 centimeters at a time to prevent the surrounding soil from shifting. Engineers follow a center-outward strategy, beginning at the middle of the wall and progressing toward the ends. To prevent the sides of the trench from caving in, vertical pulling boards are driven into the dirt and held in place by horizontal timbers called wailing. Horizontal struts are then wedged across the trench, locking the boards firmly against the earth. The building is now supported entirely by the temporary steel framework, positioned over an empty, excavated void. High-density concrete is poured into these secured 1.2-meter-wide trenches, forming a new, solid base directly beneath the wall. The temporary needles cannot be removed until the new concrete has reached its full structural strength. This process, digging a section, pouring the concrete, and waiting for it to set, is repeated for every block along the perimeter. This incremental repetition ensures that at no point is a significant portion of the building left without a direct path to the ground. In the final step, the hydraulic jacks are slowly lowered to transfer the weight of the building off the needles and onto the new concrete foundation. The dead load of the structure settles into the new base, which is now capable of supporting the weight for the long term. The needles are removed, the holes are sealed, and the exterior shoring is dismantled. Above ground, the stabilization is complete. The cracks stop expanding because the building is finally resting on stable ground. Underpinning ensures the survival of the structure by systematically replacing its foundation, a process that relies on the controlled diversion of weight to manage the forces that would otherwise lead to collapse.